Should I cut it off? No, just let it burn.
No, you could, because it's your coil. Yeah, turn it off. As you see, you're going to end up with it coming down in your burner.
You said move it down, so I did what you told me to say.
Move ours up a little bit.
Get some sand. Get some sand.
What part
Just
of
bring the
Bring
whole.
that thing over here.
Everything is supposed to have.
Put some sand on it.
Oh my gosh.
Can I spray with the distilled water?
No, sand looks better.
I do. You're not even
Okay. Put it equally, so like, I guess.
See the ring where the ring is? Just
Yeah, I
figure out
know.
where that ring is right there.
Going right here. And butter needs to go. Alright. Going on the opposite side of it, I guess. Wow, very good. Okay. Now put a crayon.
A bigger piece.
Alright, wow, okay.
What?
Maybe you should put this on here.
What? It doesn't matter.
Yes, they have to do evenly over. Okay. And then,
Sugar.
yeah, sugar has it. Okay, you have to just do a pinch of
How are we
that.
gonna put the sugar on?
Put it like on the edge right there. Oh, wow, very good. Alright. Okay.
There's a clump over here.
Okay, well now it says, light the burner and reserve the time required for each substance to melt. Okay, wait, we need time of that.
Use your watch.
Okay. Now, oh yeah, it's melted. Right. Put it in this one. Just tell me when to start.
It's gonna melt the foil.
And then match.
Didn't. It's only double. We're supposed to quadruple it.
Just move it higher.
It's only double. You're gonna melt through it.
Yeah, she said. Did you just make the quadruple it, man?
Or just double it. Should doubling it just be fine, or?
Double should be fine, especially if you don't have your burner real close to the.
What do you think that's
Move
close?
it
That's
up.
not, right?
And it still may burn through, but you'll probably at least see, you'll get your results first, so you'll know what it's gonna do. I'd say you're probably fine.
Oh, you have to go to at the time then, I guess, because.
You probably don't have to record, you can just kind of observe and see what it.
Because it says, at the time. Oh, wow.
Oh, I lied. Caught on fire right away.
Oh, look, the butter died.
Of course, you got to see what it did already.
Yeah.
The wax is gone.
Oh, well, I couldn't really tell which one melted first.
That's all right. They all pretty much
Hell, it did
went.
really quick.
Yeah, so that
The
tells you
piece of
about,
wax just completely disappeared.
that tells you that they all have what kind of melting point.
Yeah, but the
This
crayon
one.
didn't, though.
Well, or
Close to the same.
high or low. That's what-
Low.
Yeah.
So so what would you say the crayons all?
They all have low melting points.
Yeah.
That's really all we're trying to determine.
Just want me to throw this away.
Uh-huh.
So now do we just quadruple it, I guess?
You can
I just
quadruple.
quadrupled it.
Yeah, just in case, okay. That's a lot faster than I thought it would be. That works out. Okay. So now,
Maybe you could just move it up a bit.
This.
Yeah. Just throw this close to the flame.
working out a couple for sulfate. Okay, and then magnesium sulfate. Yeah. There's only 7. Very good equal in the salt.
The salt won't stay in one spot.
Okay. I guess. So I guess repeat the same thing, except this might take 2 or 3 minutes. So assume if it doesn't melt, this does not occur within 2 or 3 minutes. So these might take longer to melt.
Can't take much shorter.
Yeah.
Yeah, really.
Oh, very
Good job.
Good grief, your flame must be really hot. Let's do another one. When you light your flame,
Now?
let's do it. Let's not let near as much gas come through. Let's see.
So make it small.
Yeah. And might,
Move that out.
it's still pretty hot though. Yeah, if you, back there should be okay as long as you don't touch this part.
Watch this go.
I'll let you get that ready and then, like I said, when you light it, let's just let a little bit of gas through and
Okay.
see what it does. I don't know.
Is the
That just burned right through the foil just immediately. It didn't even. And usually on this one, because the other they catch fire and then that makes the foil burn, but this one burned right through without anything on. Because it was right in the center, wasn't it?
Yeah.
Yeah.
This is salt. The next one, we put salt and then magnesium sulfate on this one, right?
Yeah. Magnesium sulfate. You already put the copper 2 sulfate, right?
Mhm, that's the blue one.
Oh, okay. And then the teal sulfate. Yeah. Alright. Now just do the same thing.
Okay. Go ahead and get ready and I'll just turn the gas on slowly so you can smell the flame. Couple light.
Is that good enough?
Wouldn't that be too small though?
No, that should be fine.
Okay, well, I guess it's the copper 2 sulfate.
You could kind of, while you're checking that, you could be starting to get ready for the solubility part. Just kind of keep looking. You can see a little bit of change happening to one, but
And the
it's
copper
not
2 sulfate is turning white.
Alright. So it's just place a few crystals. We're doing all the tests?
Except for the conductivity.
Okay. But there's only 6 test tubes when there's 7 of these, so like that's
Yeah, you'll have to do 6 and then dump one out.
Okay. Wait, give me each other.
Or just
give me
one whole
yeah.
thing?
So how about the butter? You want to press a little bit on the butter? In there? The butter?
What about it?
You want us to put like a little bit soon? Okay.
How's your stuff doing that's clean?
No.
Only the copper sulfate.
Is it melting?
It just turned into a different color, turned like more clear, more white.
Whitish blue.
Yeah.
Okay. I think probably it's gone long enough if you want to turn it off. And then just to see what happens, you might take the wash bottle and put a little bit of water on the copper sulfate, which turned white, and watch it. It does. Away and see what happens when you put water on the copper sulfate.
Oh, it turns back to its, I guess, regular color. You can see.
Lab quest on. And I'll try to pull up the. Pull up our instructions here.
What's wrong with this?
Okay, can you read that, or do I need to turn a light off? I thought we'd all just kind of go through this together. I'm actually going to do it with you, because I'm going to see if I think my Chem 1 class can handle this when we get to gas laws.
How high can this thing go up to?
What?
How high can this go up to?
I don't know.
I don't want to like break it.
Yeah, I don't know. You know what, I guess I'm going to have to watch one of you, because I don't have a gas pressure sensor. I thought I had 4 of them. Okay,
Messing around.
what you're going to do,
Mine stopped at 224.38.
yeah, I don't.
That's the size it goes for me too.
200 and what?
200. 224.30.
Okay, and are you in kilopascals?
Yes.
Why don't you change your, do you know how to change your unit?
Try to figure it out.
Yeah, see if you can remember. So we can do millimeters of mercury atmosphere, so we can kind of compare
What do you want us to change?
to the units.
Millimeters of mercury.
Let's get it, try it millimeters of mercury, and let's try it in atmosphere, so we kind of get an idea.
This one?
Highest that goes up to is 1,682.4.
Millimeters of mercury. Okay. 1 atmosphere is 760 millimeters of mercury, so you've got more than 1 atmosphere. And kilopascals, I'm trying to remember, I don't use your Kelvin, so I just have to go back and review.
It's not reading 1 atmosphere, but we're in our atmosphere.
It's reading over.
It's reading 0.96.
Oh, okay, so we're a little below. That's going to change. You know when they talk about the barometric pressure? That's what you're reading, is the barometric pressure today. And so at sea level, you know, so at sea level we'd say we're 1 atmosphere, but that's going to vary depending on the pressure in the air for the day. So we're at 0.96 atmospheres today, it sounds like.
This goes up to 2.2 atmosphere.
Oh, does it? That's, okay, that's higher than that. I'm trying to figure out what chapter we're in, because I was going to look up how many kilopascals are in an atmosphere, because I honestly don't remember. I should, but I don't. I can't find the chapter on gases.
How much would you like me to film them?
Oh, here in a minute, they're actually gonna get some data on their little lab quest. I'd like a little bit of film of them getting data, okay?
I got it to 0.04 atmospheres too.
0.04, okay, so pretty low pressure.
So what do you want us to do with this?
Okay, I'm gonna tell you here in just a minute. Let me look at full passes real quick. So okay, 1 atmospheric pressure is 760 millimeters of mercury. I know that. I want to find the right full passes. Okay. Standard atmosphere is 101.3 kilopascals. Okay, so here's what we're going to do. The objective is to measure or determine the relationship between the pressure and volume of a confined gas, which we've already talked about. We understand kind of what it is, but we're going to get some data. We're going to use air confined in a syringe connected to the gas pressure sensor, which is what you have. The volume of the syringe is going to be changed by moving the piston. That's going to change the pressure, which is going to be measured by the LabQuest. We're going to assume that the temperature remains constant, which it should. We're not going to have much change there. And then we're going to get pressure and volume data pairs to analyze. Okay. Oops. In this experiment, okay. Connect the gas pressure sensor to LabQuest. So with the little, you've all plugged it in to the channel. So everybody that, okay. Choose new from the file menu. I'm just going to kind of walk you through it since I can't actually do it. Okay, so that's choosing a new, everyone there. With the 20 milliliter syringe disconnected from the gas pressure sensor, so you don't want the syringe connected right now. Move the piston of the syringe until the front edge of the inside black ring is, and you can see in the figure, the front of it, is positioned at 10 milliliters. I'm sorry, I was wrong. Okay, so move the front of the black. Okay, Mr. Lee, you're not going to need that connected. All you need is the syringe for this one. Okay, and then now push your piston or push your syringe till the front of the black ring is at 10. Is everybody at 10? Okay, this is to calibrate it, I think, if I remember right. To obtain the best data possible, you'll need to correct the volume readings from the syringe. Look at the syringe. Its scale reports its own internal volume. Okay, so those markings are telling you the volume in the syringe. So you right now have 10 milliliters of air, but there's a problem. Okay, because you're measuring the air right here, from here to here. What else is there that has air in it? The tip, okay? So we have to correct for the tip. And it talks about, to account for the extra volume in the system, you will need to add 0.8 milliliters to your syringe reading. So when you are at 10, you really have 10.8 milliliters. So every data point, we're going to add 0.8 to. Does that make sense? Okay. For example, with 5 milliliters, the total volume would be 5.8. Okay. You're now ready? You make noise on your list.
Triangular.
Oh, he doesn't have anything on his shape like that. Did everybody get marshmallows?
Green.
I have some right there.
I mean,
Bear Fry is number one.
no.
I'll take his, man.
No, you're not. You're gonna sit around.
What's up?
What's it called when two countries team up just to take another country's resources?
I don't think he can.
Glorious and
Right now.
No, I don't know. What are you saying?
Let's get imperialist. Let's get imperialist.
How would you be racist? Oh, you're right. Just make fun of you that make it down, make it that you're black. I'm educated and stuff like that.
Yeah, do your work then.
You have.
Or I can take 3 yellows.
Do your work.
And give you 1 green.
You
can, but you might get sick.
Yeah, whatever.
Ben, do you want the arrow pointing which way is?
No. What? I'm not taking it, I'm taking it from the marshmallows you're making. Just put your hand down so I can see what you're doing.
Yeah, put your paws out.
An inch.
Mr. Turner, will you hold up one of your models, please?
Edit that out.
Hey, that.
Baso did that in me.
Oh, wow.
I mean, they have all the communication, I don't know how it works, but they can communicate with Earth, so there's somehow they can. Okay, I'll let you, I mean, we'll leave this on while we're working, but we're gonna get started. Okay, what you're gonna do is, we're gonna make models of the molecules that are on this paper. And one of the astronauts was calling, they didn't say who he was calling, he got the wrong number. And then he told the lady he's calling from space.